Right, now we're on to lesson 2.2. This is all about linear equations. We're going to first look at identifying linear equations and functions. So I want you to write this down here. Linear equations or functions will make a line when they are graphed. There are no exponents used with the variables. So anytime you see an x squared or a y squared or x cubed or y to some other power or even square roots are technically kind of like exponents, we know that those functions then would no longer make a straight line. So it's no longer linear if it has those things. So looking at part A here, if we're just identifying linear functions, we're just going to be looking at whether or not an equation or a function that we are given is written as a linear function. So would it make a straight line? So for this first one, example A, we have g of x equals 2x minus 5. And yes, that one would be linear. It would make a straight line. We can tell because there's no x squared or y squared or any exponents with them. If we were to graph this function, it would make a straight line for sure. So it is linear. P of x equals x cubed plus 2. This is example B. We would say no, it is not linear. There's an x cubed piece right here. So this would not graph a line. It would actually graph something that almost kind of looks like an S. It would kind of go something like this. This would go on forever. This would go on forever. We won't look over cubic functions for a while, so things with cubes, but this is similar to what this one would look like. Okay, so a cubic function like this is not linear. It's not a straight line. And example C, t of x equals 4 plus 7x. Again, we would say that one is linear. There's no x squared or y squared. It does graph a straight line. So this is considered a linear function. If you were to graph it, if here was our coordinate grid, if you graph that, it would make a straight line. So it is linear, in fact. For function notation, instead of y equaling something, we can always write f of x equals something instead of the y. So all of these are written in what's called function notation. G of x, p of x, t of x. If you hear things asked to be written in function notation, basically it just says instead of y equals, use f of x equals, or g of x, or p of x, or t of x. We normally use f for function of x. This is a function using x as its input. This is a function using x as its input, but we call it function g, not function f. Okay, it's just a way to define things. So, continuing on with our linear functions here, we're going to look at what's called standard form. So standard form of a linear function looks like this. ax plus by equals c. Okay? In this case, so I want you to write this down, ax plus by equals c. And off to the side, I want you to write down that a, b, and c are all integers. Remember, that means that there's no decimals or fractions. They can be positive and negative. Integers can be positive numbers or negative numbers. They just can't have any decimals or fractions. One other thing to note, if you want to put a little star by this one, a must be positive. This first number in front of x must be a positive number for it to be in standard form. Standard form is ax plus by equals c, and a must be positive. Okay, a, b, and c are also all integers. So, for example, if we're going to write each equation in standard form and then identify a, b, and c. Okay, so it's very important to remember a, b, and c are all integers. A has to be positive. So looking at this one, y equals 3x minus 9. If we want our x and y on the left side over here, we need to move this 3x over here. How would we do that? We would subtract 3x from both sides. When we do that, it's now going to look like this, negative 3x plus y, and if it helps, you can think of this as 1y equals negative 9. Now we have just these integers, negative 3, positive 1, negative 9, all as our a, b, and c. The only problem here is a must be positive. So to change this, we multiply the entire equation by -1. So -1 times -3. -1 times +1. -1 times -9. That's going to make it become 3x, +3, -1y, or just -y. I'm going to move these out of here. Don't think we need those anymore. So -y and +9. So -9 times -1 is a +9. Now, if this is our standard form, a then is 3. We can see that right here. B then is -1. If there's nothing in front of the y, it's like a 1, and it's negative because we have minus, so -1. And C is +9. So this would be the standard form. This would be our A, B, and C value. Okay, so let's try example B here. We have -2/3 x equals 2y minus 1. Okay, we want the x and the y on the left side. So what we do to both sides is subtract this 2y on both sides of our equation. When we do that, it's now going to look like this. -2/3 x minus 2y equals -1. Well, we can tell for sure that because this is a negative, we're going to have to multiply everything by a negative. Okay, we know that at least. Okay, so what we're multiplying is definitely negative. We also don't want any fractions here. So we got fractions or decimals. Right here we see a fraction. These ones are whole numbers, but this one's a fraction. So we need to multiply by this 3 to get rid of this divided by 3. 2/3 means 2 divided by 3. So we know we're multiplying by 3. We know we are multiplying by negative. So we'll just say we're multiplying by -3. Okay, this negative piece basically just changed all of these into positive. Then we're just multiplying each piece by 3. So our first piece just becomes 2. 2 divided by 3 and then times 3. Well, the 3's kind of cancel out, so it's just 2. 2 times the 3 would be a 6. Or if it helps, again, remember that it's -2 times -3, so it's +6. Same thing, -1 times -3 is a +3. So 2x plus 6y equals 3. This would be the standard form of this equation. Now, a is just the piece in front of x, so it's 2. B is the piece in front of y, so it's 6. C is the piece on its own, this constant at the end, so it is 3. That would be standard form, and identify A, B, and C. This last one should probably be the easiest. They're already all in integer forms. 8, -6, +4, and a 0. But we don't want this extra piece here. We want it to be over here. So we just minus the 4 on both sides of our equation. And then we'll get 8x minus 6y equals -4. So again, A is in front of x, it's 8. B is in front of y, it's a -6 because it's minus, it's a negative. And C is that -4. So that was changing these into standard form and identifying A, B, and C. Part B, we're going to be using intercepts to graph a line. So for example, we're going to find the x and y intercept of the graph of this equation, then we're going to graph the equation. So now remember, this is our y-axis, it's up and down. This is our x-axis, it goes left and right. Okay, so an x-intercept just means where it touches this line. Same thing, a y-intercept means where the line touches this axis, this up and down. Y-axis, y-intercept, x-axis, x-intercept. Okay, so we're going to do this two different ways. In a sense, they're going to be the same, but for one, we're going to first change this into standard form, then go from there. On the other, we're just going to leave it like this. So if we want to change this into standard form, we're going to need to move this -4 over to the other side. So what would we do? We would be adding 4 to both sides. because we notice we don't have standard form yet. So we'd have negative 2x plus y equals positive 4. These two canceled out. 0 plus 4, positive 4. Now we can't have this negative 2. We need to multiply everything by this negative 1. So negative 1 here, negative 1 here, negative 1 here. When we do that, each piece gets changed, so it's 2x minus y equals negative 4. Now what I want you to write down is that an x-intercept, it's a point where the graph crosses the x-axis. A quick, easy way to find that is just to use your equation and set y equal to 0. And so then it's the point something 0. Same thing with the y-intercept. It's the point where the graph crosses the y-axis, this up and down one. So we just set x equal to 0. Set x equal to 0, solve our equation, and that'll help us find the point 0 wherever we're at. That would be the y-intercept. So for finding the x-intercept, we would do 2x minus, we're setting this equal to 0, equals negative 4. Now subtracting 0 means nothing changed, so we don't really need that. So 2x equals negative 4. So we would divide both sides by 2. Write in some green now then. And we'd find that x equals negative 2. So it has to be this point negative 2, 0. I'm going to go ahead and graph that right now. Negative 2, 0 is right here. That's going to be our x-intercept. Same thing. If we use our y-intercept, we're just plugging in 0 right here. So it's 2 times 0. We're plugging in 0 right there. So 2 times 0 minus y equals negative 4. Well, 2 times 0 is just 0, so we can get rid of that. So it basically says negative y equals negative 4. Divide both sides by negative 1. And we get that y has to be 4. So our y-intercept is this point 0, 4. So 0 over, 4 up. There we go. That's our x and our y-intercept. Now, if we didn't change it to standard form first, which sometimes might be easier because from this form, you're just plugging in zeros here and here and then solving really quick. You can also solve it using this one without changing it, just still plugging in the zeros. So that would look like this. Take negative 2x plus 0 and then minus 4 equals 0. We don't need the 0, so we add 4 to both sides. Negative 2x equals 4. Divide by negative 2 on both sides, and we get x equals negative 2. Just like we got up here. Same thing with our y-intercept. Plug in 0 for x, so negative 2 times 0 plus y minus 4 equals 0. Add that 4 to both sides, and you get y equals 4. So either way, using this one or these ones that we did, we're going to get that our x-intercept is at negative 2, our y-intercept is at positive 4. Once you know 2 points, you can make a straight line. You just go right through those points. I suppose I can actually extend this even too. And this will be our line then. We just found 2 points, the intercepts, and graphed right through them. And that'll wrap it up for this lesson.